Replacing the valve seals on a Vega is often a misunderstood service operation that has resulted in unnecessary and costly repair work. Valve seal replacement is important, but is not necessarily a difficult job to perform. In this program, we will demonstrate how to replace the valve seals on any Vega equipped with either the 1 or the 2-barrel carburetor. In addition to this program, your zone service instructor can make another program available to your dealership concerning valve repairs, Valve Train Service. It presents operating principles and has service tips that help you diagnose and correct valve train complaints. Improper valve stem oil sealing due to an improperly placed or worn seal can result in excessive oil consumption and in spark plug fouling. You'll recall that each cylinder of the engine has 2 valves that work together to assure efficient fuel consumption during the 4-stroke cycle. The intake valve opens to permit entry of the air-fuel mixture from the intake manifold into the cylinder. The fuel is compressed and ignited, and the exhaust valve opens to allow the burned exhaust gases to escape from the cylinder following combustion. Let's review the components of a typical valve assembly. There's the stem, the oil seal, the spring, the retainer locks or keepers, the cap, and the damper. The valves operate under extremely harsh conditions. They're subjected to rapidly changing temperatures between the cooler incoming fuel mixture and the superheated gases being exhausted. Exhaust valve heads have to withstand temperatures well in excess of 1,000 degrees Fahrenheit. At the same time, the valve stem works against the guide in which it travels, 2 metal surfaces in continuous high-speed contact, the kind of friction that could result in rapid wear. Considering these operating conditions, it's pretty obvious that the valves require lubrication, which is achieved by crankcase oil pumped through the engine block to the valve train components. But the presence of too much oil on the intake and exhaust valve stems creates problems. Excessive amounts of oil will work down the valve stem, past the guide, and into the combustion chamber. As mentioned earlier, this can result in excessive oil consumption and spark plug fouling. An oil seal is installed on the valve guide boss to control the seeping of oil past the stem and down the valve guide. The seal is a rubber-like cup that has 2 metal bands which prevent its expansion under heat and help hold the seal in place. This seal can become cocked and slip out of position because of improper installation, or simply wear loose under the valve's normal operating conditions. When this happens, the seals must be replaced. A new oil seal installation tool is available to help you assure proper seating of replacement seals. You'll see how to use it a little later in this program. Diagnosing a valve stem oil seal malfunction isn't all that easy, but it can forestall pulling the head and getting into a search for cylinder repairs. Checking the oil seals first and replacing them when necessary can help assure an efficient repair the first time. The customer's complaint about excessive oil consumption can be a good tip-off. Another is smoky exhaust when the car decelerates. When your diagnosis shows that the valve stem oil seals are malfunctioning, here's the procedure to get at them and replace them. We'll take it step by step, but first, here's an outline of what's involved. Stop the projector when you hear the tone. First, you will move the engine front cover aside. Remove the timing belt and the camshaft sprocket, then the upper timing belt cover and the distributor. Next, you will remove the camshaft cover and the camshaft, remove the valve tappet, remove the valve spring and replace the oil seal, then reinstall the valve train and all the other components. Begin by removing the hood. To do this, prop the hood in the open position and carefully remove the retaining clip from each hinge. With the aid of a helper, disengage each hinge from its support and remove the hood. Next, disconnect the battery negative cable to help eliminate the possibility of shorting the electrical system. Then, loosen and remove the Delcotron drive belt and remove the two lower screws on the engine front cover. Remove the upper retaining bolts and rotate the front cover to the side in order to allow clearance for removal of the camshaft. Note that for the next operation, it is not necessary to drain the engine coolant or to loosen the water pump bolts, since the camshaft sprocket and timing belt will be removed as an assembly. Next, remove the timing sprocket attaching bolt and remove the sprocket and timing belt as an assembly. Set the sprocket aside and allow the belt to hang free on the crankshaft sprocket. At this time, rotate the crankshaft until the timing mark is in the 1 o'clock position. This will position the pistons away from top dead center so that there will be no interference between the valve and piston when the valves are depressed in later steps. Then remove the spark plugs and set them aside. Next, remove the 3 bolts securing the camshaft timing belt upper cover to the cylinder head. Then remove the cover along with the camshaft seal and retainer assembly. So that you can remove the camshaft without having to remove the cylinder head, raise the engine to gain clearance for the camshaft to be pulled from the head. Do this by first loosening the front engine mount to frame mount bracket nuts. The next step is to remove the distributor. To do this, remove the cap, disconnect the wiring harness from the cap, and set it aside. With the vacuum advance hose disconnected, remove the distributor hold-down nut and clamp and remove the distributor. Then place a wooden block between a floor jack and the oil pan and jack the engine up until the finger on each engine mount butts against the top of the slot in the frame mount. After removing the air cleaner bolt, disconnect the ventilation tube at the camshaft cover or at the air cleaner and remove the air cleaner from the carburetor. Remove the PCV valve from its grommet at the front of the camshaft cover, then the cover to cylinder head retaining screws, and lift the cover from the head. Next, disconnect the fuel line at the carburetor and remove the idle stop solenoid if the carburetor is so equipped. This step is necessary so that you can gain clearance to install the camshaft installation and removal tool. This is the camshaft removal tool you'll be using next. Note that there is one depressing lever for the valves on each cylinder. Each lever pivots on the tool's crossbar so that a downward force can be applied by the finger end of a lever against the tappets and valves of any one cylinder. This pivoting action is accomplished by means of the depressing screw through the threaded hole in the other end of the lever. As the screw is turned clockwise, the threads in the lever ride up the threads on the screw, forcing the finger end downward, depressing the tappet and valve. This tool will be used to first depress the tappets so that the camshaft can be removed, and second, to depress the valve springs so that the valve retainer locks can be removed. Begin by positioning the tool against the cylinder head so that the attaching holes in the tool align with the lower attaching holes in the cylinder head. Align the tool so that the tappet depressing levers will depress both the intake and exhaust valves for their respective cylinders. Notice that the depressing levers should fit squarely in the notches in the head adjacent to the valve tappets. It's important that you check carefully to make sure there's no contact between the screws in the bottom of the tool and the bosses on the head beneath the tool. Contact could prevent the tool from seating squarely. These hardened screws are supplied with the tool. Torque them securely to attach the tool to the cylinder head. Now, turn the screws in the bottom of the tool downward until they just seat against the corresponding bosses on the cylinder head. This will support the downward thrust of the lever depressing screws when you tighten them. Next, apply a heavy body lubricant to the ball end of the tool's lever depressing screws. This will minimize friction and any possible scoring as the base of the screw contacts the bottom of the tool. Then, tighten the screws to depress the tappets. Use a torque wrench for the final few turns, tightening evenly from screw to screw. Approximately 10 foot-pounds is required to fully depress the tappets. If more torque seems necessary, check the tool for proper installation. Then proceed cautiously to prevent damage to the depressing levers. With all 4 sets of tappets fully depressed, remove the camshaft by sliding it forward until it clears the head. To do this, it may be necessary to remove the radiator shroud screws and push the shroud down. Next, release spring tension on the depressing levers above the tappets. Move the levers to one side and lift the tappets from the head. Since more than one tappet is being removed, be sure to set each one aside in order so that you can be sure the same tappet is replaced with its respective valve. In this way, you won't have to adjust the valves for lash when the camshaft and tappets are reinstalled. Although oil seals are replaced in sets, to avoid repetition, we'll see how to replace the seals for one cylinder only. Install an airline adapter tool to the spark plug port and apply compressed air to the adapter to hold the valve in place. Then place the valve spring adapter tool above the valve spring and, again using the depressing lever of the camshaft tool, put pressure on the adapter tool to compress the valve spring. Note that the depressing lever applies pressure evenly on both the intake and exhaust valve for the cylinder. With the spring compressed, remove the valve locks, release pressure on the spring, and remove the adapter tool. Now remove the valve cap, the spring, and the damper to give you access to the valve stem oil seal. To remove the old seal, use the air conditioning seal seat remover and installer shown here. The tool can be adapted with a 1-inch length of 3/4-inch ID pipe that will be slipped down over the seal during the removal to assure even pull on the seal. As you see, with the pipe in this position, the old seal is easily grasped and removed. When replacing one seal, it's recommended that all the oil seals be replaced, taking into consideration the length of the service procedure and the low price of the seals. The kit shown here packages a complete set of 8 seals and a plastic safety cap that fits over the end of the valve stem. To install a new oil seal, first place the safety cap over the valve stem, then slip the seal over the cap and down the valve stem. A light coat of oil will help prevent the seal from twisting. The cap protects the seal from being sliced or punctured by any burr or slight irregularity that might be present on the valve stem. As mentioned earlier, there's a new seal installation tool that you can use to help assure proper seating of the oil seals. With the safety cap removed, fit the tool over the valve stem above the oil seal. Then, depress the seal down the valve stem until the lower white line on the tool, marked ADJ for adjustable, aligns with the boss on the cylinder head. Maintain pressure momentarily, then back off the tool, making sure the oil seal remains seated. Then, clean and reinstall the damper, spring, and valve cap. This completes the oil seal replacement procedure. Stop the projector when you hear the tone. Next, using the spring adapter and camshaft tool, compress the spring and reinstall the valve locks, assuring that the locks seat properly in the valve stem groove. Grease can be used to hold them in place while releasing tension on the spring. Remove the airline adapter from the spark plug port, reinstall the plug, and torque it to specification. After assuring that the crankshaft is still in the 1 o'clock position, reinstall the tappets over the valve stems and tighten down the depressing levers of the camshaft tool. Position the camshaft into the cylinder head until the journals are seated in their respective bore and install a new gasket and the timing belt upper cover with the retainer plate and seal in place. Then torque the 3 retainer screws to specifications. Next, align the crankshaft timing mark to piston top dead center and reinstall the camshaft sprocket and timing belt as an assembly. When doing this, be sure that the alignment pin in the sprocket corresponds with the hole in the camshaft hub. To secure the sprocket, hold it in place with one hand to maintain tension on the timing belt and insert the center bolt with the other. In addition, Be sure the timing belt is seated properly in the grooves on the water pump pulley. You can check to be sure the camshaft and crankshaft are aligned properly by inserting a drift pin or similar tool through the cover hole as shown. If alignment is proper, the tool will clear the small hole in the sprocket. With this completed, lower the floor jack to seat the engine on the mounts and replace and torque the mounting bracket nuts. The service procedure is completed by reinstalling the timing belt cover, the Delcotron drive belt, the ignition distributor, the camshaft cover, and all other components that were removed. Then check and adjust the ignition timing and replace the hood. In this program, you've seen a step-by-step procedure that avoids the necessity of removing the cylinder head when replacing intake and exhaust valve stem oil seals. By following the steps shown in this program, you should be able to perform the replacement of the oil seals well within the allotted time.